All right, this is 4.8, day 2. We're finishing the problem where we had the average temperatures of Cape Town. Now we want to find out how much does my graph shift to the right or to the left. And this is a little harder to tell. And the easiest way to tell is where does it maybe touch on that principal axis. So we're going to go back up to that graph in just a moment. So to find the horizontal shift change is where does it fall on the graph, and then does it create that initial sine wave function where it starts on the principal axis, goes up all the way to the top of the amplitude, and then comes back down and around. So let's go back to the graph. The initial point on the graph was in January. It was at 28. This was my maximum point. Remembering sine waves start at the principal axes. So they've actually already denoted it on the graph right here, where they call it point A. And then that point A starts here, and it goes up, comes back down to the principal axis, and then finishes off. And that is one revolution of the traditional parent function. So we have to figure out how much it shifts to the right. Do you agree it shifts to the right? So here's January, February, March, April, May, June, July, August, September, October. So it's shifting 10 months to the right. And that point is 10 months, 21.5 degrees. You can kind of see it also in our chart. Here is October. This is the shift where it starts. So then my C of the equation has shifted. I lost my connection again. Yeah. Shifts right 10 months to where the first sine wave will begin. So then the C, we have to think opposite. Instead of adding 10, would equal a negative 10. Now we're set to put all the pieces into our equation. The T is like an X, what we're used to. They, in this textbook, an IB textbook uses a letter T instead for this problem. So Y equals, the amplitude was 6.5. We constructed the sine function. The B was found from the period. We found the B to be pi over 6. The T is our variable. We shifted 10 months to the right for its first revolution, so minus 10. And then we shifted 21.5 degrees up on the principal axis, so that's 21.5. And this is what you'll do in your homework, is you will be given a set of data, you will graph that data, you will find the pieces to the equation and write what the equation actually is. This textbook problem, I'll show you where it is in the textbook if you want to look at it. It's just another practice problem if you wanted to see about the high tide and the low tide and how to find the data. I'm going to skip it just because this problem took a while to do, but you can see about it as the answers in the textbook where they found the period. This case was 12.4, and they've used get the x and graphed it. Okay, so we're going to move on to what your homework will look like today. These are from a SL textbook. Some schools use a American textbook like us, and now we're going to supplement with the IB textbook, and so I have some for you. So the first set of problems is on page 245. Very similar to what we just did. We give you the monthly temperature, and you graph it out and find all the pieces. And then on page 235, we don't ask you to write the equation, but we ask you to find the equation of the principal axes, what's the period, what's the maximum value, and what's the amplitude, and then graph it also. These are also online on my main downloads page as a PDF, so if you wanted to print it off. And then I have textbooks for you to use today if you want to write the problems down.